You're good to go.
The problem for our third one was more shadows, and the problem was a spotlight on the ground shines on a wall 15 feet away. A man 6.5 feet tall walks away from the light toward the wall at a speed of 5 feet per second. When he's 11.5 feet from the building, determine what is the length of his shadow and how fast is the length of his shadow on the building changing. So I drew a picture, and this is a light, and it's shining onto a wall right here. And this would be the distance between the light and the wall, which was stated in the problem to be 15 feet. And there was a man walking towards the wall away from the light that is 6.5 feet tall, so he's right in the middle kind of. So we're going to call this distance between the light and the man X, and we're going to call the height of the wall Y, or that spot right there Y. And if you want to separate this into two similar triangles, you can say that this length over here is 6.5 feet, and this length right here can be defined as X. And then the other triangle over here, this length can be 15 feet, and then this variable right here will be said to be Y. So to find the length of the man's shadow, you can set up a proportion. So it'll be 6.5 feet over X equals Y over 15 feet. And you can cross multiply and get X times Y equals 97.5 feet. And then we know that X is equal to 3.5 feet because this length right here of the whole distance between the light and the wall is 15 feet, and the man is an X distance away from the light. And if you do 15 minus the 11.5 feet that he said the man was away from the wall, you get 3.5. So you can substitute 3.5 in for X. So then you can divide by 3.5, and you get Y equals 27.857 feet. So the length of the man's shadow is 27.857 feet. And then next for B, we are finding how fast the length of the man's shadow on the building is changing. So we can use the same problem we found over here in part A, xy equals 97.5 feet. So first we need to define the derivative of that. So we would use first d last plus last d first. So that'll be x times dy over dt plus y times dx over dt equals 0 because 97.5 is a constant. So the derivative of that is always 0. So next we're going to subtract y times dx over dt. So now we have x times dy over dt equals negative y dx over dt. So then next we're going to divide by x to get dy over dt by itself. We're left with negative y times dx over dt divided by x. So we're going to go up here, and you can substitute in the values that we know, and we know that y is equal to 27.857 feet, which we found in part A. And we know that dx over dt equals 5 because in the problem it stated that the rate at which the shadow is changing is 5 feet per second. And then we know that x is 3.5, which we also found in part A by subtracting, getting that x equals 3.5 feet. Then once you enter that into your calculator, you get negative 39.796. So the length at which the shadow is changing is negative 39.796 feet per second.